Well, hello everybody. My name's Tom. My email is twrigley@ucsb.edu. And after looking at the poll that I sent out to determine what time my office hours would be, I've decided to make them Monday from 7 to 9 Pacific Standard Time. That is California or UCSB time for anyone who's not aware of that. And it'll be on the same link that I have posted on Goucher Space that says Tom's Zoom Room or something along that line. I'm making this recording just because I've got numerous emails just saying I can't make section for one reason or another. And with the pandemic and not being able to be in class in person, and I know there's people in China and all over the world, so them making, let's say, a 3 o'clock or a 7 o'clock class is almost impossible to do. And since it seems like we have a decent portion of my sections, at least, that fall into that category, I've decided to make this recording of kind of what I was going to go over in section, post it beforehand, and then I'll still go over a little bit in section, but have it more based on like questions after I give the examples of what to do and maybe some more examples that build off the material that I have covered in section. I've also got some questions on homeworks. So homeworks are due email to me at this point. If anything changes, I'll let you guys know. The due dates are posted on the Goucher Space website. It's on the information PDF if you don't know exactly where that is yet. And when you're sending me the email, just make sure that you title it my homework with your name. And if you can save it with your name, that'd be more convenient, of course, just when I'm going through and grading everybody's. I don't want to accidentally mix somebody else's up with somebody else's just because some error when I was saving it due to how you guys sent me the email. So now getting into section after all the nitty gritty. So this is going to be our first section, I guess you could say, even though it's just a recording. So pretty much it's going to be about the theory of interest. We'll look into simple and compounding, the differences. I know you guys gone over this a lot in class, but we will definitely look into I, V, and D. Those three things you will use in at least 4 more classes that I remember, or at least that I've used so far when I was an undergraduate, and I still use them today. Like they come up in exam IFM and exam LTAM. So when you guys are studying for those, you still need to know these 3 basic functions, because if you don't know them, you can't really get almost any of the questions right. So learning them now will definitely be a big help going forward. And when we're talking about exams, if you are an actuarial student, which this class is pretty much just based on the FM exam, so I assume almost everybody here is, but if you're not and just taking it because this is interesting too, I completely understand that. It is a very interesting course, so I'd understand exactly why you take it. But if you are one of those actuarial students, I always believe they're offering an exam in December and February. I recommend taking the exam in February. It gives you a couple extra time to study. You can also take it in December. I've taken an exam before, after, and during the class. So if you need advice or just want to talk to somebody about that, feel free to come to office hours or send me an email and we can set an appointment to talk about that. And then we will also look into, on this worksheet, nominal and effective and the differences. So let's start with simple versus compound. So we start at the top. We know that a simple interest formula is just 1 plus I times the amount of time we have the money in there. That's our accumulating factor. And then our compound interest is this 1 plus I to the power of t. So as we know that when we've gone over in class, or at least Professor Duncan has, that compounding interest will increase at a much higher rate than the simple interest formula. So here's a first example of this. The Bank of UCSB gives 2 options to invest $1,000. You can either receive 10% simple interest each year or 8% compound interest. You plan to invest for 6 years. How much more can you make if you invest correctly, and how about if you do it in 10 years? So we'll first start with the 6 years on the left, and then we'll go to the 10 years on the right. So we'll use the formulas up above in simple and the compound interest. So we have 1,000 times 1 plus I for the simple interest, so that 6 years would be times 6. And we know that I is equal to 10% or 0.1. So using Excel, I'm sure everyone knows how to use Excel, but if you do not, to start a formula, hit equals, and then it would be 1,000, just like over there, times 1 plus 0.1, the interest rate, then times the amount of time we will be investing, which is 6 years, and then we get 1,600. Now, what will we get if we do it compoundly? So if the interest makes money, and every year we have an effective interest rate of 8%. So it would be 1,000 times 1 plus I for the effective, which is 8% here, to the power of 6 for the 6 years we'll have invested. So over here, that is still, yet again, 1.08 instead of the 1.1 because we don't earn 10%, we earned 8% when we do compound, and we get that there's a slight difference. So we're not done yet because it said how much more would we make if we invest correctly. So in this case scenario, just because of how the interest was set up and time period, at the 6-year mark, we make exactly $13 more and about 12 cents if we invest correctly. Now, let's look at the 10-year mark. So we're going to do pretty much the same exact thing. So it'd be $1,000 your starting amount times 1 plus the interest rate, which is 10% for simple. And then what do we do there? We're now going to multiply by the amount of years. So here we get 2,000. So in 10 years there, we were able to double our money. So what will we do if we invest compound in 10 years? Let's see. So it's 1,000 times 1.08, because that's our effective interest rate compounding, to the power of 10 for our 10 years. And now if we invested 10 years, what is the difference? Here we'd make $158.92 pretty much more if we invested properly. So we'll just add difference over here just to make it a little bit more clear when I post this document later. And yes, I will be posting the document later just for everyone to go through. Maybe you want to see all the Excel stuff, the basic formulas I've used over here, or just play around with it. You have some examples and maybe do them on your own. Just get a little better with Excel. As you're all aware, Excel is a big thing for actuaries to use, so getting accustomed to it is something I highly recommend. And now let's look at a graph of how much we can make at time periods. So we still have the 8% for compounding and the 10% for simple. So we see at time 5, our simple interest, which is in blue, is significantly higher than the compounding interest. So I'm just going to drag it down a couple years. And we see here for the simple interest, it pretty much increases at a constant linear rate. Now let's do the same thing for the compounding interest. As you see here, even though that it's a lower percentage, 8% compared to the simple interest of 10, it starts to creep up and then pass the amount of interest you earn. And this is because of the compounding factor. So we see at 20 years in, you're just about 50% more than the other you would earn from just earning simple interest. So now let's finish out the whole graph. We see that the simple interest continues to form linearly, as it always will, but the effective compounding interest goes exponentially higher growth, and it is significantly higher once we get into 30 or 40 years. And this is just because the effective interest rate, or which we will talk about later and you guys have covered in class with Professor Duncan, is the same each time period when you're compounding use interest, but it changes when we use simple interest. So going over here for our next example. So same setup as the previous example. So we have 10% simple interest and 8% compound. When the effective interest rate is the same for each method. Is it going to be the same or is it not? And when will the effective interest rate be twice as large for one than the other if it is? So for the effective interest rate, we know it's the percent of interest made in a time period. So it's the accumulation at time t minus 1, and time t minus divided by time t minus 1, the entire quantity. So as we know, for our compound interest, it's always 8%. So we need to find out when our simple interest will be equal to 8%, or it will always be 10%. So let's just check if we do year 5. So 1.5 minus 1.4, right, would be, and then we would have to divide that by 1.4, right? So now we're going to do that with Excel. 1.5 minus 1.4 divided by 1.4, and we get 7.14287. So moving forward, we know that at this point it's actually less than the 8% at time 5. So now let's check the first time period just to make sure it is 10% to see if the formula is right. So that'd be 1.1 minus 1, because at time 0 we don't make any money, divided by 1, and we get 10%. So here it does work, and we line everything up all right. So you guys are going to need to do just, I'm just going to do this to make it quicker, but I would use the formula, and I'll set that up afterwards. So we know it is 1 plus 1 times, whoops, I apologize, guys. Forgot the equal sign. Minus 1 plus 0.1 times the previous, divided by 1 plus 0.1 times the previous time period. We'll just do that for us, and that is 0. So let's just drag this down, and we see it is pretty much, I made a mistake. Oh, yep, here we go. I forgot an extra parentheses, which is why it did not end up right. So there we go. Now we get our answers to look more specific. So notice sometime between time 3 and time 4. I'll leave it to do exactly for you guys to set up the exact time period, but the way to do it is we know it is 1 plus t times 0.1 minus 1 plus t minus 1 times 0.1. Well, I'll just forget about what we divide by. But that is equal to, that is equal to, it's going to be 0.1 times just 0.1, and then we have to divide it by, and then we divide it by our 1 plus t minus 1 times 0.1. And that is our exact formula on how to get it. So we see that it's right here, and then we just need to set this equal to the 8%. So pretty simple. That's all you guys will need to do to get the exact answer. But from over here, we can see it is sometime between 3 and 4 years to the effective interest rate will be the same. Now let's move on to I, V, and D. As I spoke about earlier, this is a very important thing just to have all these formulas memorized, as they're going to come up continuously throughout this class, and at least 4 more classes that I know of going forward. So we know that V is 1 divided by 1 plus I, and D is either 1 minus V, or I divided by 1 plus I, or I times V. So if we have I that is equal to 6%, what will V and D be? So we know for V, it would be 1 divided by 1 plus I, but in this case, I is 6%, so 0.06. And in Excel, that is equal to about, we can change that percentage, apologize, about 94%, or 0.94. This is rounded off though, but in class, use a more precise answer. Don't round it off exactly like I did. And then we know D is I, so 0.06 divided by 1 plus I. And let's see what this is equal to. And that is 1.566, or what percentage was it? Almost 6%. So if you subtract these, they are the same. I'm going to go to a couple more decimal places to show that. So we know that D is equal to 1 minus V, right? So let's double check this. We have our V, and now let's see if 1 minus V is equal to D. So what is 1 minus V? So 1 minus v, we can do 1 is equal to 1 minus our value of v, which is 0.56. So we're just going to double check this is right. So this is equal to a slight difference apparently. Well, they should be exactly the same, but as you guys can see, maybe I probably used the formula wrong or rounded something slightly off. But as you guys can see, the numbers are pretty much identical. They should be 100% identical. So the formula works. And now let's try, we know it is also I times V. So let's try 0.06, 0.06 times V. Then 0.06 times our value of V, which is yet again 5.66 or 0.566. So each of these cases, make sure that the D are the same. So there are many different ways to find D, making it easier to do if you're giving just V or I. You can do whatever one you prefer to do. So moving forward now to looking into nominal and effective interest rate. So we know that nominal and effective interest rate can be a little bit confusing the first time you look at it. So when you're giving the nominal and you need to get to monthly or effective, we know that we can just divide by, let's say if we're going to monthly, we can just divide by 12. But if we're getting effective for the year and we need to get to the effective for, let's say, quarterly or monthly, we then have to do a little bit of extra work to do it. And as we know here and gone over in class, that to get the effective interest rate, it is 1 plus I is equal to 1 plus I prime, which is in this case the monthly or monthly interest rate, divided by m to the power of m. So let's go to an example of how to do this. So in example 1 here, we have I is equal to 5% effective annually, and we need to find if it was compounded quarterly and monthly. So to start this off, we're going to do quarterly. So we know that it is 5%, so effective interest rate is 1.05. Now, we know that we need to change it to find the I prime over here of 4. So we have 4 here in each one of the m's. So if we're rising it to 4 on the left, to get it down to normal, we can rise it to the 1 divided by 4 over here. And then we also then, we'll be left with this. After that, we still aren't there yet. We still have 1 plus I divided by m, not just the I for quarterly. So we then need to subtract 1. And then after that, we have our interest rate, but that's just for the each quarter. So that's the I divided by m. So now we want to find the I value. So we do this times what's m when we do quarterly? 4. There's 4 quarters in a year. There's 52 weeks. 52 weeks. 4 quarters, 2 semi-annually. 2 semi-annual, we'll just say. And 52 weeks, I know some people have told me they thought it was 48 weeks or something along that line, and along with 12 months. So those are the main time periods you'll need to know. This one, I think, for some reason, people get wrong the most, the weeks, but we've also can go over, let's say, every 5 months we do it, or a different time period, just maybe you get a weird question like that, and that's all you'll have to do. But now let's go to monthly. So going to monthly, we got to find the interest rate from our 5% effective for the annually. So what are we going to do here? Pretty much the same thing as last time, you guys are right. So the 1.05 to the power of 1 divided by the m, and in this case, since we're monthly, we know m is equal to 12. And then from there, same thing as we did last time, we know right here we still need to subtract 1 because we have 1 plus I prime divided by m. And then we need to multiply by m to get the I for the entire year. Now, so when we have 1 time period, 4, and 12, let's see the difference in I's. And this is just in the 1 year. So we know this is 0.5 or 5%. And then we know also just calculated the other ones for 4. So then for 12, and I will make these a little bit more so we can see more decimal places. So we see as our time periods decrease, a smaller effective interest rate will get us the same amount of money at time period 1. We'll still have 5% for the entire year that we accumulated, even if we get an effective interest rate that is lower going forward, like with a monthly or then quarterly. And if we go to continuously, using the delta as you guys have covered in class, it will even be lower. And we know how to get delta. It would be the natural log of 1 plus I. In this case, it's 1.05. And that is by far, I'll move that right up. So delta is the lowest. So if you ever have a question on what would the difference between delta I to the 12th for the effective or I effective it is, we know that the more time periods we accumulate in a year, the smaller the effective interest rate needs to be for us to have that same percentage of interest accumulated at the end date. Now, we're going to go on to some more just pure examples. Maybe this is something you'll see in the homework similar to, or maybe on the midterm or final or something along that line. Not super complicated yet, just because we're still just starting and it is week 1 and you guys have only had 1 class, but something for you guys to see and maybe to help you with your homework and maybe bring up some questions that you didn't exactly know how to do, and then I show you a couple ways on how to start the question, and then you guys can figure it out. So example 1, you invest $1,000 today and it earns an effective interest rate of 8.5% for 5 years. At time, you invest $3,000 more dollars. And then at time 8, you now have $5,040. What effective interest rate did you earn after year 5? So let's see exactly what we have at time 5, because we can't just go to from time 1 to time 8 just because we had that extra money in at time 5. And we know that we can't just add the $1,000 to the $3,000 because we can earn money on that at 8.5%. So at time 5, we'll see what our starting $1,000 is equal to. So just as before, we'll do the 1,000 times 1.085 here. And is it simple or compounding? Well, as we can see here, it says effective. Sorry about that. So as we can see here, it says effective. So that means it is compounding. So we go up for the time period, which is 5 years. So that is exactly the amount of time that our $1,000 would be worth at time 5. But we also know that we added $3,000. So add the 3K into it. So we would do this plus 3,000 to the amount of money we have at exactly time 5. And then we know what we have at time 8. So the difference between time 5 and time 8 is we have $54,000 at time 8, and we know that is equal to, I'll make that look a little nicer for you guys. It's going to be equal to our value right here, which is 5403.65669 times 1 plus our effective interest rate for this time period to the time period, which is 8 minus 5, or 3. So how are we going to solve this equation to find out our I here? And you may be asking, why do we have 3 here instead of just the effective interest rate for all 3 years combined? That's because if we're looking for the effective interest rate for the year, we know our time periods are 1 year. So even though the effective interest rate we learned in the time period will be significantly larger, we want to know what we get each year. Maybe in a different question, we'll have something similar, and we want to figure out what money we'll have at time 10 or earlier in the year, and then we want to make sure we have the right I to use going forward. So to start this, we will need to divide our 5400 divided by what we got at time 5. So we got here is about 1.2 almost. And now to get what are, right here we have, this is 1 plus I to the third. So 1 plus, and that is what that is equal to. So after that, we then need to figure out just what I is equal to. So I'm just going to do both of the next steps. So as we've gone over this previously, so it is this up to the 1 divided by 3, and then we need to subtract 1 to just go what the I is. So our I turns out to be about 6.24%. So that is significantly lower than our 8.5% that we started with, but that is exactly what we earned during those time periods. Now let's go on to the next example. So here, John wants to buy a TV. The one he wants costs $150 today, but he only has $100. So he waits 2 years to buy the TV. He knows that he'll earn $10 at the end of year 1, but the TV will cost $150 at year 2. What interest rate will he need to earn to be able to buy this TV? So as you guys can see here, we start, right now we know the TV will accumulate in value also, but we got to see how much money we will need to earn so that we will be able to afford this. So we start with $100, and we need to get this to time 2. So here, we're going to do 1 plus I up 2, but we also earn $10, right, at time 1. So we also need to accumulate that. And what will we accumulate this at? It'll be up to the 1 to get that to time 2. So we can just drop that off. And we know this will be equal to 155. So from here, to figure out what I is, we're going to need to use the quadratic equation. I'm sure everyone remembers what that is, but just in case, I'm going to write it down for you guys. It's negative b plus or minus the square root of b squared minus 4 times a times c, by all over I mean divided by, okay, so negative b plus or minus the square root of 4a times c, all divided by 2a. And here we have the a is equal to 100, the b is 10, and the c is negative 155. It's negative because we need to subtract it over to get this is equal to 0. So let's figure out exactly what I is. So we have to do the quadratic formula. So it is negative b, so it is negative 10. We're just going to start with the discriminant, which is the square root. So the square root of negative b squared, so b is 10, so square that, minus 4 times, we have a, which is 100, and then times negative 155, and we get that is 249. So are we going to add or subtract this to get to our 1 plus I? Since we know that our b is negative 10, we're going to add this to it because we don't want a negative interest rate, because if we subtracted it, we would get a negative interest rate, and we know that if we have a negative interest rate, we can't really earn $155 if we don't have $155 going forward. But so that is why the quadratic formula gives you 2. You need to figure out which one it is, and by that I would just pretty much use common sense. So we know we need to subtract $10 from this, so minus 10, and then we have to divide by 2a, which is here $200. So we go this divided by 200, and we get that 1 plus I is equal to 1.19, but we're looking for I, right? Not just 1 plus I. So what do we need to do here? We need to subtract by 1. We know that I is equal to this, and then we are done. So we figured out Y is, and then we are solved everything. So I'm hoping to see anybody here in section or in office hours, whatever is more convenient for you guys. As always, bring questions to section or office hours. I'll have a couple more examples to cover in section when it is live, which is Wednesday at 3 or Wednesday at 7. You guys would have got an email from me, of course. This will be posted along with the worksheet on Gaucho Space probably later today, hopefully, but definitely before class. I'm going to try to continue to do something like this for the students who can't attend class or section just because of either scheduling conflicts or most likely it seems to be you can't physically make it just because of the big time difference from where you are living because of the pandemic. So thank you guys for listening. Wish you guys all the best, and I'm here to help if you ever need anything.